Now, the good thing is this is your x and y. So you can actually use that x and y to check your solutions by substituting those values. And I would like for y'all to do this with me, please. So the y is 0, so I put 0 equals 2 times negative 2 plus 4. And then I would solve to make sure that it's true, and it is, so that would be our solution for that, for that equation. Now we would do the same, oh, I put 4, I didn't mean to, sorry. 0, there it is. Now I'm going to do the same thing with the other. So I have 0 equals negative 2 plus 2, which means 0 equals 0. So both equations are true. So that means this truly is a solution. So in this case, we have one solution. Just like when we solve equations, you can have one solution, you can have infinitely many, and you can have no solution as well. And we're going to look at those other two here in just a second. Now, I want to talk about the characteristics of these equations when we have one solution. What do you notice about the slopes? We have a slope of 2 and a slope of 1. What can you tell me about them? Are they alike? So then you would say that they are, if they're not alike, then that means they're what? Different. Yes, different slopes. Because we have different slopes, automatically that means we have one solution. That means they will intersect at some point. Now I'm also going to tell you that graphing doesn't work every time. It works nice when we have whole numbers as our solutions, but sometimes it's decimals, it's fractions, it's money or whatever. So sometimes it can be challenging on a graph. So I'm letting you know that now. We are going to look at different ways to solve these throughout the next couple of weeks. All right, here's your next one. I'm going to go ahead and set up my x and y axis. So here's my y and here's my x. That is not good. Try that again. So I'm going to start with my y-intercept at negative 3 and a slope of negative 1. So it's going to be up and to the left. So that's the one in red. So now we'll do this one in orange. It's a pretty similar color, but it's all right. 1, 2, 3, 4, 5. So it would be here with the slope of negative 1 also. What do we notice about these two lines? They're parallel and they have the same slope. So they are parallel and same slope. Well, we know that parallel lines have the same slope, right? So what does that mean about the solutions? Is there? What do we know about parallel lines? They'll never cross. And if our solution is where they cross, if they're not ever going to cross, then what does that tell us? No solution. Okay? So parallel lines have the same slope, which means in turn they have no solution. All right, let's look at one more. I'm going to set up my axis here. If you notice, this first equation is in the right format. The second is not. So I'm going to go ahead and fix it by dividing everything by 3 to get y by itself. So y equals 3x minus 3. So I'm going to go ahead and graph this first one. We have a y-intercept at -3 and a slope of 3. There's that. And when I go to graph the second one, I also have a y-intercept at -3 and a slope of 3. What do y'all notice? It's the same equation. So when I go to write this down, it's going to be the same equation. So what does that mean about the solutions for this system? Say it again, Emma. Infinite. Oops, if I could spell, that would be fabulous. Infinite. Nope, still can't spell. All right. So one thing I want you to do, I want you to look at this question here, and I want you to think about it, and maybe you can answer or jot some things down. What do you think these 3 types of solutions, when you look at those equations, what do you need to be looking for to know if they are one solution, infinitely many, or none? And we actually talked about this a little bit. I'll let everybody answer. Good. Okay, so if there's one solution, then that means they just plain and simple have different slopes, right? That would be key. That means they would intersect eventually. Infinitely many solutions would be the exact same. Good. I like that. Exact same. And while no solution would mean they are parallel, right? And we know the rules for parallel mean same slope, different y-intercept. Very good.